So thank you, Sean, and thank you, Balchem, for this great opportunity. It's my first time in UK, and I'm very excited to show one of the projects I did at UW Madison while doing my postdoc fellowship there. So I think I need to thank Dr. Mike Vandenberg for setting a perfect platform to discuss and highlighting the importance of lysine to maximize milk production in dairy cows. So I think it's, we all know that lysine and methionine, those are frequently limiting amino acids. And from the contribution perspective, lysine contributes almost 9% in milk protein, which makes the point that it's very crucial to balance for the dairy cows. Then there are some challenges to attain the lysine concentrations in the diet, so which probably some of them because of some European regulations of not using blood meal. So then comes to the use of rumen-protected lysine to attain those requirements for cows. But one of the problems with this lysine is that it's very sensitive to the heat damage, and depending upon how the feed ingredients are being processed, lysine digestibility can be affected, which turns to the point that rumen-protected products might be an optimal option to use this in the diets of dairy cows. From the literature perspective, several studies have been conducted which tested the evaluation of rumen-protected lysine supplementation, but there is some discrepancy between the results. And another reason that almost 30% of studies, they had either 15 or more experimental units per treatment, and the rest of 70% of studies whatsoever have been published so far, they had less than 15 or experimental units. So we don't have those kind of studies where people have tested rumen-protected lysine products supplementing with hundreds of dairy cows. So one of the aspects to address this uncertainty is doing meta-analysis, where you can combine all of the literature whatsoever is published, and then you combine those into the statistical modeling using cool mixed modeling approach, and then you come up with some interesting findings. So based upon some of the previous guidelines, NRC 2001, they recommended lysine and methionine at 7.2 and 2.4% of metabolizable protein supply. And when we looked into the literature, there was no recent, not really recent update on the new numbers. So NASEM in the 2021 variant, they suggested that these numbers needed to be updated. So that's where we thought that previously there was only one meta-analysis which was done by Dr. Robinson in 2010, and since then it's been now 14 years, and we didn't have any meta-analysis. And in Dr. Robinson's meta-analysis, we had quite some limited data on lysine, so we thought to update those numbers using some recent literature review. So before conducting the meta-analysis, we had some hypotheses. So we hypothesized that supplementation of rumen-protected lysine during the lactation period will improve the postpartum performance in dairy cows. And also, we wanted to address what could be the optimum concentration of lysine in metabolizable protein to improve the performance in dairy cows. So with these two hypotheses, we set some objectives, and a couple of those objectives. So one of the objectives was to determine the impact of supplemental lysine when it is fed in a rumen-protected farm during the postpartum period on performance, and also identify the optimum concentration of lysine as a component of metabolizable protein supplemented to lactating cows. And the last objective, we wanted to test if the supplementation of metabolizable lysine as a percent of MP is dependent on the metabolizable methionine, since we all talk about that those two amino acids are very critical and they rely probably on each other, so we wanted to test this question as well. So regarding the inclusion criteria, we chose to include all those experiments which were done using randomized complete block or complete block randomized design. And in those experiments, the experimental unit, either cow or pen, it was clearly defined. And the supplementation of rumen-protected lysine products started after calving. And then whatever experiments we included in that data analysis, in each single experiment, there was a control group where the scientists, they did not supplement any rumen-protected lysine, and there was another group which was called as treated group, in which either one or more levels of lysine were supplemented as rumen-protected lysine product. So then, since there are several rumen-protected lysine products which were used in all those experiments, so we wanted to standardize this based upon the concentration and intestinal digestibility of lysine. So in order to standardize metabolizable lysine calculation, we used those values. And then rumen-protected lysine was a component of TMR, or either it was top dressed in those experiments. One of the important aspects of this meta-analysis was that since there were quite some experiments and some used NRC, some used NASM, some used CNCPS. So what we wanted to avoid using different models as a confounding effect. So we wanted to collect the information on the ingredient composition of postpartum diets so that we can use a single model to recalculate all the nutrient composition and to establish the analysis. And then whatsoever experiments were reported in the literature, they had to report the least square means and the measure of error of the individual responses. So we conducted literature search using some search engines which are listed here, and then we used some of the keywords, lysine dairy cow, lysine transition cow, rumen-protected lysine, and rumen-protected lysine transition cow to identify those experiments which were done since 1980 to all the way to 2024. And whenever the information was not available in the manuscript, we contacted the authors and we received that information. So this is just to illustrate how the process was being completed. So first of all, we used those keywords and we put them into the literature search engines, and we got close to 7,000 articles. And then since we use several engines, so almost 4,000 articles categorized as a duplicated article, so we removed them, and then we had quite some articles to screen according to our eligibility criteria, which I discussed before. And then after screening, so we had to exclude 2,000 some articles because some of them were conducted in different other species, or some of them were conducted in the in vitro settings, or majority of them just did not fulfill our eligibility criteria. And then finally, we had 43 articles which we tested, and eventually we got down to 12 articles having 13 experiments which met the criteria of this meta-analysis. So those articles were included in the analysis. So finally, we had 12 manuscripts with 13 randomized experiments, and those randomized experiments had 40 treatment means. Out of that, 17 treatment means were with control, and 23 treatment means were with rumen-protected lysine treated groups, and we had a data close to 600 pairs lactating cows. So we collected information from those experiments, and then we also collected information on the responses of interest. I will not go into detail of the mathematical approaches. I hope you believe us that we applied the standardized approaches to analyze this data. So briefly, we analyzed this data according to the two core questions that we wanted to address. The first question was, what happens when you add rumen-protected lysine? Irrespective what was the dose, what was the commercial brand, irrespective of the fact, what happens when you add rumen-protected lysine in a diet of the cow and on the productive performance. And the other question we wanted to ask, what is the optimum amount of lysine as a percent of MP and how it is being interacted with methionine as a percent of MP in the analysis. So all of the experiments, they had the random effect of experiment for the statistical modeling. So this is the table I put there just to show you that both treatment groups, the control with no rumen-protected lysine and the rumen-protected lysine products, in terms of NEL, crude protein, metabolizable protein, you can see that those numbers, they are pretty similar, but the real difference was here in the control groups. You can see here there is no lysine source there in the terms of rumen-protected, and here you have 19.3 grams of metabolizable lysine here. And overall diet, you can see here, this was turned into 160 grams across all of the experiments data that we put together there. So I just wanted to highlight the point that there was not specific reason to choose NASM because I worked throughout my PhD program using NASM, so I feel to calculate the ingredient compositions in the NASM, but I also did the activity of putting data into CNCPS, and I must appreciate the efforts of Dr. Van Amberg here, who published this big data analysis recently, where you can see here they compared the NRC, NASM, and CNCPS for different predictions of amino acids, and you can see here the values, they are pretty close to each other, and the concordance correlation coefficient among those, they are pretty close to each other. And when we reanalyzed the data using CNCPS, the interpretation of our data was pretty much similar. So, okay, so let's go to what happens to the responses after supplementation of lysine. So this is called the forest plot. Let me walk you through this forest plot. So on the left side of this forest plot, there are the rows, which are the references of the experiments which contributed into the data analysis. Then every row is basically a comparison. So every row is a comparison between a control group versus a treated group which supplemented rumen-protected lysine product. The central black line response, when it hits to 0, it tells you that there was no benefit of the intervention. In this case is rumen-protected lysine supplementation. If the black dot moves towards the right side of this black solid line, it means there was a positive benefit on the response variable, and in this case the response variable was milk yield. And if this black dot moves towards the left side of this black solid line, it means that there was a negative response on the milk yield. The dashed maroon line, it represents whenever a dot point is touching this black maroon line, it tells you that the response was significantly affected between the two groups. And then there is the gray shade. You can see here the gray box. So the gray box is based upon the precision of each comparison. So you can see here some comparisons has larger gray box, some experiments has smaller gray box, and that tells you how much the weight of those experiments was put into the analysis. So for example, in Poland et al., you can see here the weight in the statistical analysis is a lot more than the Han et al., because probably Poland et al. Had more number of cows in their experiments. So when you have more number of experimental units, you get to get less standard errors of mean. So those experiments are more precise, let's say in this way. So we wanted to standardize for that. So then in this forest plot, you can see what happened to the overall response to the milk yield when you feed or you don't feed rumen-protected lysine. So if you see all over at the bottom, this diamond shape, it hits the maroon dashed line, which tells you that the overall response was positive, and it increased 1 kilograms of milk when the cows were supplemented with rumen-protected lysine. But then we wanted to do a subgroup analysis to answer one of the very common questions from the farmer's perspective. Hey, when I need to start supplementation of lysine to my cows? So do I need to start in the early lactation, or do I need to start in the mid lactation? So based upon the two distinct cohorts in our data, so we did a subgroup analysis where we separated those experiments which were conducted in the early lactation versus those experiments which were conducted in the late mid lactation. So you can see here experiments which were conducted in the early lactation. When those cows were supplemented with rumen-protected lysine, they produced 1.5 kilos more milk compared to their control groups. And when the lysine was supplemented in the mid lactation, the response was still there, but the magnitude of the response was slightly less, close to 0.8 kilograms per day. So then we wanted to address another common question, which is called duration of feeding. So based upon the two distinct cohorts, we did another subgroup analysis where we wanted to see how much should be the duration of feeding rumen-protected lysine. So based upon the data we had, we were able to split into two groups. One where experiments supplemented lysine more than 70 days, or experiments where they supplemented lysine less than 70 days in milk. So you can see here when the experiments when the cows were supplemented lysine more than 70 days after calving, so they produced 1.5 kilos, and when they did not, they produced some milk, but the magnitude was less, and overall there was benefit. Then another common question is, do I need to supplement or do I need to meet the requirements of lysine just for the high producing cows or just for the low producing cows? So depending upon the data points that we had, so we had the median value of 32.2 kilograms, so we categorized those two groups, one where the experiments were done in the high producing cows where they were producing more than 32 kilos, or the cows which were producing less than 32 kilos. And you can see here, it doesn't matter about when it gets to the level of milk production, the cows were still producing 40 grams or 30 grams depending upon their milk production level when they were supplemented with rumen protected lysine, which tells that the cows, it should not be, the decision should not be based upon low or high producing. Yes, you can decide whether I need to feed more lysine or less lysine depending upon the requirements, but both group of cows, they do need amino acids for the optimum production. So that was the one set of analysis that we did. Then another set of analysis that we wanted to address is what is the optimum concentration of metabolizable lysine as a percent of MP, which is associated with increased performance. So in this mixed model analysis, let me explain you one figure because the rest of the figures will be just be similar in terms of interpretation. So in every figure you will see on the y-axis there will be a response variable. On the x-axis there will be metabolizable lysine as a percent of MP. And then those triangles, they represent the experiment, and the connecting lines, the dashed or dotted connected lines, they connect the number of treatment means within that experiment. And then the size of this triangle is based upon whether the experiment was more precise or less precise. So if the experiment was having with more experimental units, more number of cows, less standard error mean, so those experiments carry more weight. So the weight in the analysis was the random effect. So you can see here some experiments has a lot more weight than the other experiments. So interestingly, as I mentioned that cows who were supplemented with lysine, they had a benefit in terms of the productive performance, but we did not observe an effect of rumen protected lysine on the dry matter intake, which tells that the increase in milk production or the milk components was not because the cows consumed more feed, but because cows just got more efficient in producing more milk yield. So look at the milk yield figure. So you can see here there was a linear relationship between metabolizable lysine as a percent of MP, and as you go to the so 7.2 or 7.5% was initial, you can say the criteria which was being used a lot, but you can see here even we don't have much data points beyond 8.5%, so we don't really know what will happen if we feed after 8.5%, but with a certain confidence you can say that at least until 8% metabolizable lysine as a percent of MP was linearly associated with this increase in milk yield. So we observed the same linear relationships for the milk fat yield and also for the milk protein yield, and this milk fat yield or milk protein yield linearity not because they were driven by the fact that those cows produce milk, but also when we analyzed the milk fat concentration or milk protein concentration, those were also went up. So so both milk yield as well as the milk components, they got benefit when there was an increase in the metabolizable lysine. So when we analyze this fat corrected milk yield or ECM, so you can see still there is a linear relationship. Like I said, we don't have information in the literature what will happen at the increased level of lysine. So this is something where I would say the data is lacking, and I hope that we get to know what will happen when we feed those levels. An interesting aspect of this meta-analysis was to see what happens between metabolizable lysine and metabolizable methionine. So we found an interaction between those two important amino acids. So you can see here on the y-axis is the feed efficiency. It doesn't matter if you have based upon fat-corrected milk or energy-corrected milk, the response was similar. So let's just look on the energy-corrected milk here, based efficiency. So you can see here on the y-axis is the efficiency, on the x-axis is the metabolizable methionine, okay? And now every line, depending upon the color of the line and the symbol you can see here, we categorize different levels of metabolizable lysine. So you have from 5 to 9%. So you can see here, it's not only that I have met the lysine requirements, so I don't need to meet the methionine requirements. Both critical amino acids, they interlink to each other. So you can see here when you have, I put there here two scenarios. So when you have 7.4% lysine and you have less methionine, let's say in this part of the figure, so you get to have this much efficiency. But when you have same amount of lysine, but you increase the methionine 2.9% something here, so you get to increase the efficiency, which tells you that not only lysine but also the other critical amino acids need to be balanced to achieve the maximum efficiency. So this slide, I will just be brief on this slide. So this is to see what happens to when the lysine is being fed to the cows, what happened to the different amino acids in the blood. So you can see here that cows which were supplemented with lysine, they had an increased lysine in the blood concentration. Interestingly, they also had increased arginine, which is also we have now very much good data that arginine is also relevant in terms of increasing milk production. We just conducted an experiment with more than 110 cows at the University of Florida with rumen-protected arginine, and we find the cows were producing 2 and 2.5 liters more milk when they were supplemented with arginine. So certainly, lysine is not only increasing its concentration when it's fed in a rumen-protected form in the blood, but it also triggers some other amino acids to interplay for the improved performance. So finally, supplementing 20 grams per day of metabolizable lysine using rumen-protected lysine in the postpartum period, it increased the blood concentration of lysine, which makes us to believe that those whatsoever commercial products were used in those experiments, they were able to increase the concentration of lysine, so they were able to escape the rumen and get to absorb at the intestinal level. And then when rumen-protected lysine was fed in early lactation or it was fed for an extended duration, that was the case when the cows get most of the benefit. And when you increase lysine as a percent of MP from 6.5 to 8.5%, it linearly increased 1.8 kilograms of milk yield, 2.5 kilograms increase of milk yield adjusted for fat-corrected or energy-corrected, and then we had 70 or 100 grams increase in milk yield, in yield of protein and fat, respectively. So the interesting fact was the increments in production performance, including the level of milk yield and the components, they were independent of the fact that the cows did not consume more dry matter intake, which improved the feed efficiency in dairy cows. So some of the limitations which we got to know after doing this project and some of the future directions are, we really don't know what happens to the nulliparous cows. And we know that nulliparous represent almost 30 to 35% at any given farm. Huh? So, but we don't have literature where we can tell for very certain that how would supplementation of rumen-protected lysine to nulliparous cows, because those cows, they are still growing, they are partitioning those amino acids for their own body growth. So we have to see that if they also get the same kind of benefit or not. And then whatsoever experiments we were able to collect and whatsoever other experiments which didn't fit to our eligibility criteria, but we got to see them, people hardly report the effects of rumen-protected lysine on the health events. So we were not able to see what happens on the health effects. But since we had the milk composition data in our meta-analysis, so we were able to get the information on the somatic cell score. interestingly, when we ran the analysis between lysine as a percent of MP and somatic cell score, so cows who were receiving more lysine, they had less somatic cell score, which explains the point that the cows might be getting some benefits in terms of the mammary gland health perspective. And there is a very cool data from University of Illinois in field of Dr. Cardoso group, where they conducted some experiments on unprotected lysine, and they showed that it improves the immune function, and it also helps to reduce the anti-inflammatory markers in transition cows. So probably there is something going on with lysine which improves the immune function in dairy cows. So, but we have to see when it gets to supplement on a bigger scale and to see if it helps to reduce the somatic cell score or improve the other health benefits. And lastly, we still don't have the large dose titration experiments. Majority of the experiments, as I showed in that figure, we don't know really what happens beyond 8% because we don't have the data, but the linearity of the slope suggests that we might get more benefit. But depending upon the requirements and the milk production, as Dr. Vandenberg was suggesting, that cows are producing 60, 70, 80 liters of milk yield. So depending upon the requirement of cows, we might see this linearity even beyond 8% of metabolizable lysine. So with that, I would like to thank you for the invitation and the listening.